An introduction to functions. To be a function, one value of x should give only one value of y. In this example, let's take the value of x here. X is equal to 2. X is equal to 2 will give 2 values of y. So this is not a function. To determine if something is a function, we can do a vertical line test. So in the example on the left, our vertical line, if I move the line around, it intersects the curve at only one point. So this is a function. For the circle, you can see there are multiple points of intersection between the vertical line and the circle. So this is not a function. So is this a function? Vertical line, only one point of intersection, yes, it's a function. Next example, only one point of intersection between the vertical line that I'm moving here and the graph, so yes, this is a function. Multiple points of intersection, this is not a function. Only one point of intersection, so this is a function. There are two types of functions, and we can do something called a horizontal line test to determine which type of function we have. So here's the horizontal line. There's only one point of intersection, moving this line up and down. This is called a one-to-one function. A one-to-one function has an inverse. In this example, there are multiple points of intersection between the horizontal line and the curve. This is called a many-to-one function. It does not have an inverse unless you restrict the domain. So a vertical line test to see if you have a function. So yes, this is. And a horizontal line test to see if it's a one-to-one function. And yes, this is a one-to-one function. There's only one point of intersection. So vertical line test, only one point of intersection. So this is a function. Horizontal line test, there are multiple points of intersection. This is a many-to-one function. It does not have an inverse unless we restrict its domain. Real numbers. The complete set of numbers from minus infinity to plus infinity here can be represented like this, using this notation. It's saying that x is a member of all of the real numbers. Yeah, all the numbers on the number line are real numbers. You can see the same for like the range in terms of y. So y here is a member of all the real numbers, so it can take any value from minus infinity to plus infinity. The domain and range of a function. Example 1. Our function is 2x plus 1. The domain is the set of values of x, and the range is the set of values of y. And in this graph, x can take any number along the number line here. So we can write x like this. And y can take any value along the y-axis there. So we can write y like this. It can take any real number. Example 2, the domain, clearly this time, x can't take any negative values, so x is greater than or equal to 0. This is the domain. And the range on the y-axis, is y is greater than or equal to 0. So we can't have any negative y values. In this example, the domain, the set of values along the x-axis, clearly that is x greater than or equal to -2. And the range along the y-axis, y is greater than or equal to 0. We can use this function machine here. The domain represents any value of x that goes into the function, into function g, and the range is the output. So we have the input here and the output here. Example 4, the domain x has to be greater than or equal to 0, and the range y is greater than or equal to -3. Example 5, the domain x can take any value along here except 0. When x is equal to 0, there's an asymptote, so x can't be equal to 0. The range on the y-axis, so y can be any real value, any value along the y-axis, but it cannot be equal to 0. Y not equal to 0, because there is an asymptote on the graph there. Example 6. We complete the square to get this. The vertex will be at 3 minus 7. So the domain, x can take any real value. The range, the lowest point here is y equals -7, so y is greater than or equal to -7. So the completed square form here is really useful. Think about the domain and range for the following functions. If you pause the video, work out the domain and range, and then play the video again. Going back to example 6, this is a function, but it's not a one-to-one function because it fails the horizontal line test. There are multiple points of intersection here. But what we can do is restrict the domain. So let's say if I restrict the domain here to x is greater than or equal to 3. So now this part of the curve no longer counts. So we're left with this. Now the function passes the horizontal line test with its restricted domain, so it has a one-to-one relationship.